Hi students, in this session I am going to discuss chemical bonding topics. In chemical bonding I am going to do 8 videos students. 7 or 8 videos I am going to do. This is quick revision for competitive exam and shortcuts. I am going to give some shortcuts also, which is most important topics. Okay, first in this video I am going to do Lewis dot structure and formal charge. Lewis dot structure. According to Lewis, valency electrons writing like a dot. That's it. So in previous video, I have done electronic configurations. If you have any queries, go through the topic. Based on electronic configuration, outermost we have to select. Outermost you can pick out, and outermost how many electrons are there. That electrons in that particular atom we have to represent. Okay, so look into some examples. Lithium 1s2, 2s1. It is outermost shell. So here we are writing valency electrons. Valency electrons is nothing but outermost shell. Else we call it as last shell. Clear? Yes, this is outermost shell. If you write shell-wise representation, yes, this is 1s, 2s. Clear? That's all students. You are going to write this one like a dot. Lithium. Okay? Dot. That's it. Not only lithium. If you look into first A group elements, lithium, sodium, potassium, rubidium, cesium, francium. Francium is radioactive element. If you will write for sodium, sodium also 1 dot. And if you write for potassium, it's 4s1. So actually outermost shell here 3s1. This is 4s1 like that. The entire family, the entire group, you will get only 1 dot. Based on this, we will come to know it valency electron is 1. It belongs to first group. Okay. Now next one. We take some examples. If you people write order wise also, your wish, or else randomly I am writing some examples. Nitrogen. Nitrogen atomic number 7, right? So 1s2, 2s2, 2p3. Exactly of filled. Okay. 2p3. This is outermost shell. Outermost shell, how many electrons, students? Yes, 5 valency electrons. We are going to write here 5 valence electrons. 1, 2, 3, 4, 5. Like this we have to write. We have to follow Hund's rule. We have to follow Hund's rule. First filling, then pairing will start. What is Hund's rule? In electronic configuration itself, I had given idea. If you have any queries, please go through the topic and come back here. Follows Hund's rule. Clear, students? So you don't write like this. Don't write like this. This is not correct representation. Okay, it has 5 electrons, but whenever it forms the molecule, nitrogen molecule, some interchanges will be there. When you are writing atom, element, we have to represent like this. Okay, now oxygen. Oxygen 8. 1s2, 2s2, 2p4. Clear? So outermost C 1, 2, 3, 4, 5, 6. 2 unpaired electrons. 2 electrons means this is paired. This is unpaired. Okay, coming lectures you will come to know, coming videos, unpaired electrons, what is the importance, unpaired electrons. Unpaired electrons only participate in bond formation. Clear, students? Now next one. Atom. One more I am taking. Suppose fluorine is there. Fluorine atomic number 9. Right? 1s2, 2s2, 2p5. So this is outermost shell, right? So 1, 2, 3, 4, 5, 6, 7. This is unpaired electron. It has capability to form only one bond because one unpaired electron. That's why halogens are monovalent atoms. Halogens, fluorine, chlorine, bromine, iodine are monovalent atoms. In periodic table, monovalent atoms halogens and hydrogen. Why I am writing this point? In coming videos, I am going to upload hybridization topic. There we are using these words. That is why just you can revise here. Then it is easy for working shortcuts in hybridization topic. Clear, students? This is the way we are writing Lewis structure for single atoms and elements. Now I am going to give for molecules. How to write for molecules? Molecules. First one, I am giving neutral molecules. NH3. 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 What is the NH3 name? NH3 is ammonia molecule. Ammonia molecule. And next one, O3. This is one of the important example, ozone. Next one is CO2 molecule. CO2 molecule. Okay. So now ozone molecule, CO2 molecule, these three we will discuss. I am giving one question to you. So try it. One charged species I'll explain and give. So ammonia molecule, ozone molecule, CO2 molecule. Now ammonia molecule. For writing ammonia molecule or any molecule, we have to follow certain rules. Rule 1 is find out central atom. Pick out central atom. So find central atom. Center is nothing but only one person, right? So here in given molecule, I have nitrogen and hydrogen. Two elements are there, and which is less number of atoms. Which is less number of atoms. That is central atom. Clear, students? That's it. Find central atom. Second point, central atom valency electron. Central atom valency electrons we have to find out. And third one is, what is this? Bonded atoms. Bonded atoms, electron. Now we'll calculate first electron, students. Nitrogen. So among nitrogen and hydrogen, definitely hydrogen is central atom, right? Central atom, 5 valence electrons, 5 plus. Central atom valence electrons I have written. Next, bonded atoms. What are bonded atoms here? Hydrogen, no? Each hydrogen 1 electron. 1 plus 1 plus 1. Totally 8 electrons, right? So this 8 electrons according to some rules. Another rule. According to Lewis. Fourth one is, according to Lewis, which atom or which element, which atom is having 8 electrons in the valency shell. 8 electrons in the valency shell. That is stable. That is stable. Clear, students? So 8 electrons, we call it as the rule, octet rule. Octet is nothing but 8 electrons. Okay. So what is octet rule? Define octet rule also. One of the Important theory question. Now we will fill the electrons around nitrogen. Actually, nitrogen is pyramidal in shape. As of now, we know many points. But when he writing Lewis dot structure, no idea about shape of the molecules. You can take it in normal way also. Nitrogen 1, 2, 3, 4, 5. Right? Before we have taken nitrogen atom, Lewis dot structure, right students? Now hydrogen. Each hydrogen has one electron. Atomic number is 1. It has one electron. So if you write Lewis dot representation, how hydrogen, how you can write? Yes, like this. Clear? That I am writing here. For formation of molecule, some interchanges will happen. Okay. So next one here, another hydrogen. And this is another hydrogen. Clear, students? That's all. These two are sharing. These two are sharing, overlapping. Then we are getting the bonds like this. This is ammonia molecule according to Lewis. Okay. So 8 electrons actually we have calculated, no, whether it is satisfied or not. Check it. So here 3 bonds. Each bond means 2 electrons, right? So each bond 2 electrons. How many bonds, students? 3 bonds means totally 6 electrons. 6 plus 1 lone pair is there, right? 1 lone pair is there. 1 lone pair. So then what happened? 1 lone pair means 2 electrons. Totally 8 electrons. Yes. Whatever we have calculated, we arranged here. This is Lewis dot structure of ammonia molecule. Clear? Now, next one. Try to write CO2 molecule. CO2 molecule. Carbon. Around carbon, we have 4 electrons because carbon is 40 group element. Okay, 4 valence electrons. And what about this oxygen? 1, 2, 3, 4, 5, 6, like this. And oxygen totally 6 valence electrons, 6 we are arranging like this. Now, these two are sharing. Sharing means which bond it is? Yes, covalent bond. Clear, students? That's all. This is CO2 molecule Lewis dot structure. Clear? Okay. Now, whether it is satisfied 8 octet rule or not, we have to check it. See this carbon, around carbon, how many bonds are there? How many bonds? 4 bonds. 4 bonds means, yes, it's 8 electrons satisfied. And what about oxygen? 2 bonds means 4 electrons. 4 plus 2, 6. 6 plus 2, 8. Oxygen also satisfied. Even this oxygen also satisfied. And above example, ammonia also, we can check it. See, around nitrogen, how many bonds? 3 bonds. 6. 6 plus 2, 8 electrons. Yes, nitrogen satisfied. What about hydrogen? Hydrogen only 2 electrons, no? Each bond, how many electrons I said? 2 electrons, right? How hydrogen is satisfying? So what is the next rule? Duplet. Duplet. According to Lewis, the atom is having 8 electrons in the valence shell stable, and duplet. Duplet is nothing but which is having 2 electrons. Which is having 2 electrons also stable. That's why noble gases all are stable gases. Clear, students? Like that, another examples also you can try. Oxygen ozone molecule I am giving here, students. Remaining examples you can do. I am giving one question. Everyone try this one. CO3 2 minus and PO4 3 minus. These two species which we are seeing frequently in question papers. Clear? So you can try if you are not getting. So next video definitely I'll give the solution. O3 molecule. O3 molecule. This. Finally you will get structure like this. You can check it. This is Lewis dot structure of O3 molecule. Clear, students? Okay. Next video, I am going to do formal charge calculations and hybridization topic, students. So ozone molecule clear? Any doubt? Ozone molecule. So here valency electrons. See, if you write electronic arrangement, it will be more clear. You can write like that: oxygen 1, 2, 3, 4. Next one, what is this? 5, 6. Okay. So for arrangement of molecules, I am writing like this. Look into this one. Okay, six electrons is oxygen. This oxygen also 1, 2, 3, 4, 5, 6. Clear, students? This oxygen, check it, same thing. 1, 2, 3, 4, 5, 6. Clear? Clear? Okay. Now these two electrons sharing. Mutually sharing. Catch this point. So this bond belongs to both the atoms. Equal sharing. Equal sharing is nothing but covalent bond. Okay, covalent bond. This is also covalent bond. But here what happened? It 3 twos are 6 electrons only. This oxygen not satisfied. No. Now this oxygen 1, 2, 3, 4. 1, 2. 2 bonds means 4 electrons. 4 plus 2, 6. 6 plus 2, 8 electrons. But this is not satisfied. No. That's why these electrons are given to this oxygen. That is why it forms day 2 bond. So day 2 bond. So what is that? Coordinate covalent bond. Out of 2 atoms, only one is sharing, other one is kicking. So this is the way we are writing the structure. Clear, students? Now calculate valence electrons. You can go for the same technique what I had given here. If you want to calculate, you can calculate O plus O plus O. That means 8 plus 8 plus 8. So valence electrons only we have to take it. So valence electrons is 6. 6 plus 6 plus 6. Totally 18 electrons. 18 electrons, whether it is satisfied or not, check it. So here 1, 2, 3 bonds. 3 bonds means how many electrons, students? 6 electrons, right? And next one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 plus 6, totally 18 electrons. That's all. This is O3 molecule structure. Okay. So what is coordinate covalent bond also I will explain. Covalent bond is nothing but covalent bond mutually sharing electrons. Mutually sharing electrons. Coordinate covalent bond is nothing but it is a special type of covalent bond. Coordinate covalent bond. Special type. Okay, one video I will do based on coordinate covalent bond, special type of covalent bond. In this, only one atom gives the electrons or shares the electrons. But above case, 2 atoms equal sharing. Below case, only one atom is sharing electrons. Clear, students? Carbonate ion, phosphate ion also try yourself if you are getting fine. Otherwise, next video I am going to give solution. Okay, students, thank you. Thanks for watching.